Hello students, let's kick this off with a fun thought. Have you ever wondered why the same song sounds different when sung by your favorite singer and when sung by, well, your less talented friend? Or why you instantly recognize your mother's voice even if she's calling from another room? That's because sound has three key characteristics: loudness, pitch, and quality. These are like the fingerprints of sound, unique to every source. And the best part? We can actually see these sound patterns on the screen of a C.R.O, a cathode ray oscilloscope, which shows the wave pattern of sound. Cool, right? Now, let's zoom into the first characteristic, loudness. Imagine you're gently tapping a drum with your fingers. Soft sound, right? Now give it a good whack, boom. Much louder. That's loudness. It depends on the amplitude of the sound wave. The bigger the swing of the wave, the louder the sound. But here's the twist: loudness is subjective. What sounds loud to you may be soft to someone else. For scientists, we need an objective measure, and that's called intensity. Intensity is just the amount of energy a sound wave carries per second per unit area near your ear. And fun fact, our ears are most sensitive around 1 kHz, which is why alarms often use that frequency to grab attention. Let's make this visual. When you strike a tuning fork softly and place it before a microphone, the C.R.O shows a wave with small amplitude. That's your faint note. Strike it harder and you see a wave with large amplitude, but notice something important: the frequency doesn't change. Both soft and loud notes have the same pitch and quality. Only the amplitude, the height of the wave, changes. This is why we say loudness depends on amplitude, not frequency. So, whether you whisper or shout, your voice still has the same pitch, unless you're excited and your voice goes squeaky, but that's a different story. Now let's dig into what affects loudness. First, the energy of the sound wave reaching your ear. A powerful speaker in a concert blasts way more energy at you than a tiny phone speaker. Second, your ear's sensitivity. Did you know human ears are not equally good at hearing all frequencies? We are champions around 1 kHz but struggle with very high or very low tones. That's why a dog whistle can drive your pet crazy, but you don't hear a thing. Finally, two sounds of equal intensity may not seem equally loud if they have different frequencies, because our ears' response changes across the sound spectrum. So, loudness is like perception, while intensity is cold, hard physics. Alright, let's take an example. Suppose you have a soft sound with amplitude of 1 and a loud sound with amplitude of 2. Which one has more intensity? Well, intensity is proportional to the square of amplitude. So, the ratio of intensities is I2 divided by I1 equals open bracket A2 over a 1 close bracket squared. This means if you double the amplitude, the intensity becomes 4 times. That's why a small increase in amplitude makes a huge difference in how loud something sounds. No wonder your parents always complain when you slightly turn up the volume. So, let's wrap up. Sound has three main characteristics: loudness, which depends on amplitude and is subjective; pitch, which depends on frequency and tells us how shrill or deep the sound is; and quality, which depends on waveform and gives every sound its unique signature. With the help of C.R.O traces, we can actually visualize and compare these properties. In short, amplitude gives us loudness, frequency gives us pitch, and waveform gives us quality. Together, these three make every sound distinct. Remember this trio because they'll pop up again in both exams and real-life curiosity. And that's it for today. I hope now you can not only hear sounds but also truly see and understand what makes them unique. Until next time, Keep listening, keep questioning, and keep enjoying the music of physics.